Welcome to the fascinating world of organic chemistry, the study of carbon-based compounds. Organic chemistry focuses on carbon and its compounds. Here's methane, the simplest organic molecule with one carbon atom bonded to 4 hydrogen atoms. Let's understand what makes carbon the foundation of organic chemistry. Carbon has 4 valence electrons, which allows it to form 4 strong covalent bonds with other atoms. Carbon is unique because it can form single, double, and triple bonds, giving incredible structural diversity. Most importantly, carbon can bond with itself repeatedly, creating long chains and ring structures. Here's a simple carbon chain. Each carbon atom connects to the next, forming the backbone of organic molecules. Now let's explore the different types of bonds carbon can form. A single bond consists of one pair of shared electrons between 2 carbon atoms. A single bond is represented by one line connecting 2 carbon atoms. A double bond consists of 2 pairs of shared electrons, making it stronger and shorter. A double bond is shown with 2 parallel lines, indicating 2 shared electron pairs. A triple bond has 3 pairs of shared electrons, the strongest and shortest carbon-carbon bond. A triple bond uses 3 parallel lines to show the 3 shared electron pairs. Hydrocarbons are the simplest organic compounds, containing only carbon and hydrogen. Alkanes contain only single bonds between carbons and are called saturated hydrocarbons. Alkanes follow the general formula CnH2n+2, where n is the number of carbon atoms. Here's ethane, the simplest alkane with 2 carbons. Each carbon is bonded to 3 hydrogens and 1 other carbon. Alkanes contain at least 1 carbon-carbon double bond, making them more reactive than alkanes. Alkanes follow the formula CnH2n, having 2 fewer hydrogens than alkanes. Alkenes have at least 1 carbon-carbon triple bond, making them even more reactive. Alkenes follow the formula CnH2n-2. Functional groups are specific atom arrangements that give organic compounds their characteristic properties. Common functional groups include alcohols, aldehydes, ketones, and carboxylic acids. Each has unique chemical properties. Alcohols contain a hydroxyl group, which is an oxygen-hydrogen pair bonded to a carbon chain. Aldehydes have a carbonyl group at the end of a carbon chain. Ketones have a carbonyl group in the middle of a carbon chain. Carboxylic acids combine a carbonyl and hydroxyl group, making them acidic. Isomers are molecules with the same molecular formula, but different structural arrangements. Here are 2 isomers of butane. Both have 4 carbons and 10 hydrogens, but their structures are different. Structural isomers have atoms connected in different orders, creating distinct molecules with different properties. Organic chemistry is fundamental to understanding life and modern technology. Organic chemistry is everywhere, from the proteins in our bodies to the plastics we use daily. Every living thing on Earth is built from organic molecules, proteins, DNA, carbohydrates, and lipids. Modern medicine, materials, science, and energy production all rely on understanding and manipulating organic compounds. By studying organic chemistry, we gain insight into how life works at the molecular level. Let's review the key concepts of organic chemistry we've learned. Carbon's ability to form 4 bonds and connect with itself creates unlimited molecular possibilities. Hydrocarbons provide the basic framework, with alkanes, alkenes, and alkynes representing different bonding patterns. Functional groups like alcohols and acids give molecules their characteristic chemical behaviors. Isomers teach us that how atoms are arranged is just as important as which atoms are present. Ultimately, organic chemistry is the chemistry of life, connecting molecular structure to biological function.